All right, let's just jump right in. What if I told you that one of the most basic things we do, something we do thousands of times a day without a second thought, is just plain wrong? And what if that one tiny mistake is the real reason for some of the biggest, deepest mysteries in all of science? I mean, think about it. Everything we know, everything we've built, it all starts with one fundamental action. From telling the difference between a rock and a tree to building a supercomputer, it all hinges on this one thing. It's step one for pretty much everything. And that act is making a distinction. Seeing this and not that. Separating an object from whatever's behind it. A 0 from a 1. It feels so obvious, so completely natural, that we never ever question it. It's the bedrock of our reality. Well, today, that's exactly what we're going to do. We're going to pull on that thread and ask a pretty wild question. What if, at the most fundamental level of reality, the separation we see everywhere is actually just an illusion, an idea that we project onto the world? So, to see where this potential flaw comes from, we first have to appreciate the incredible tool we use to make all these distinctions so precisely. And that tool, of course, is mathematics. You can think of it like this amazing, super powerful toolbox. It's the thing that lets us build skyscrapers, send probes to other planets, and map out the universe. And we trust it, right? We trust it because it works. And it works because it's built on this incredibly solid, logical foundation. And this is why we put so much faith in math. It's not just a bunch of random ideas. It's like a fortress of logic. You start with clear definitions, so everyone's on the same page. Then you lay down a few simple assumptions, your axioms, things you just agree are true. And from there, you build this whole universe of proven ideas, or theorems. It's clean, it's logical, it's powerful. So, armed with this amazing toolbox, we get to work, drawing lines. We use it to draw a hard line between 1 and 0, and bam, you get the entire digital world. We use it to draw a line between the scientist and the experiment, which is the whole basis of science. We even draw a line separating ourselves from the rest of the universe. But here's the thing about tools. Every tool has its limits. And it turns out that this fundamental act of drawing lines, of forcing distinctions on the world, well, it comes with a hidden price tag. It creates these deep, shocking problems that show up in both math and our understanding of reality itself. So what is this price we pay for seeing difference everywhere? Well, according to this perspective, our perfect toolbox might be causing the very problems it's trying to solve. Our obsession with separating things creates these huge cracks in our knowledge. So let's take a look at where those cracks start to appear. The very first crack shows up right in the heart of our supposedly perfect toolbox, mathematics. And it has to do with something that feels like it should be the simplest thing in the world. This slide just nails the problem. On the left, that's what we feel a line is, right? It's smooth, it's continuous, there are no breaks. But on the right, that's what a line is in mathematics. It's just a collection of totally separate individual points. You see the disconnect? Our math isn't actually describing a smooth line. It's describing an infinite number of dots sitting next to each other. It describes the stops, but not the journey between them. Now to fix this, to paper over these gaps and make the line of dots feel smooth, mathematicians came up with a genius patch, the idea of infinity. The thinking goes, if you can cram an infinite number of points between any 2 points, then for all practical purposes, the line becomes continuous again. Problem solved, right? Well, here's the kicker. This way of thinking argues that concepts like infinity and all the irrational numbers like pi that go on forever are basically useful fictions. They're like gnomes and elves. I love that analogy. They help make the story work, but you can't actually go out and find one in the real world. I mean, you can never write down all the digits of pi. You'd literally run out of matter in the known universe before you could. They're incredibly useful ideas, but maybe, just maybe, they aren't real. Okay, so this isn't just some weird, abstract problem for mathematicians. This exact same habit of ours, of forcing sharp distinctions onto everything, causes absolute chaos when we try to apply it to the physical universe. The entire scientific method is built on the picture you see here. It's the core assumption. There is a clear, hard line separating you, the person with the clipboard, and the thing you're measuring. It seems totally obvious. I am me, that is a rock. We're separate. Except when we zoom all the way in, it turns out nature doesn't draw that line at all. At the quantum level, the line between the measuring device and the thing being measured completely dissolves. They're not two separate things. They're one single interacting system. The separation we feel is a useful illusion for our everyday world, but at the fundamental level, it's just not there. So what happens when we force our idea of separation onto a universe that is actually seamless? Well, the universe protests. It gives us back all sorts of bizarre results. This perspective suggests that all that quantum weirdness isn't really weird at all. It's just what a connected reality looks like up close. It suggests that fundamental particles aren't really tiny little balls, but more like ripples in a single fabric. It might even explain mysteries like dark matter. Maybe it's not some invisible particle, but just the effect of this single, undivided substance on a massive scale. These aren't problems with the universe. They're ghosts created by our flawed way of looking at it. So, if our main tool for understanding the world, making distinctions, is actually the source of the problem, what's the alternative? How do you even begin to think about a reality that isn't made of separate parts? Well, the proposal is a radical shift in how we see everything. Forget about separate bits and pieces. What if the universe is really made of one single, continuous, flowing substance? Everything we see, a star, a planet, you and me, we're not separate objects. We're just temporary shapes, like waves or whirlpools, in this one unified cosmic ocean. So how would you even do math for something like that? Our current toolbox is built for separation, not wholeness. The source suggests we need a new concept, what it calls the in-between. Now think of this not as an answer, but more like a formal confession. It's a symbol you'd put in your equations that basically says, warning, true continuity lives here, and our numbers can't quite capture it. It's a placeholder for our own ignorance, and maybe, just maybe, it's the first honest step toward a new kind of physics. And that brings us all the way back to the biggest distinction of all. If the line we draw between us and the universe is just an illusion of our perspective, if it's all one seamless, flowing reality, then what does that make you? You're not just a person living in the universe. You are the universe, having the experience of being a person. Now that's a thought worth sitting with.